All right, so here's 5-2. We have the example. I might go through the example again and then do the assignment with you. So the sum of two negative non-negative numbers is 30. Find both numbers if the sum of twice the first and then the square of the second is a maximum. So let's just break that down first. You write down the important parts. So we have two numbers. So I'm going to let x equal the first number. And then y can be the second number. And then write an equation. So the sum of them is 30. So we know that, so that's secondary. What we know is the secondary. What am I looking for? If both numbers, if the sum of twice the first plus the square of the second is a maximum. So I'm just going to let that equal m. So this is what I have so far. So we know that the first and the second together is 30. And we know this. We have too many variables here. So I'm going to let y equal 30 minus x. So before I do the calculus, I'm going to put in 30 minus x, and then I'm going to do some algebra. So do you know how to expand this? 30 times 30 is 900. Multiply them together, and then double it. So together it's negative 30, double it, it's negative 60, and then x squared. And when you square a negative, it's going to be a positive. We're going to combine like terms so that we have x squared minus 58x plus 900. So I'm going to take the derivative, and the derivative here is 2x subtract 58. And I'm going to make it equal to 0. So if I solve it, I get 29. So that's a critical value. I also need to know the ends of it. So if I want to find this as a maximum, it's like the absolute maximum in this area, I'm going to create a little table of values. So first of all, x could be 29. If x is 29, and then if you substitute 30 take away 29, it's 1, and then you could actually plug in and solve it. So that would be 2 times 29, that's 58, plus 1, so that's 59. Now, the problem with 29 is, if I did a number line for the derivative, first of all, I have to understand this, that if they're both positive numbers, if I look here, remember if I make this equal to 0 and I add x to the other side, x can only be between 0 and 30, or else it'll be a negative number for y. So it's between 0 and 30. If I plug in a number into the derivative, if I plug in a number smaller than 29, it's negative. If I plug in 29 and a half, it's positive, and it creates a minimum. And the problem is I want to create a maximum. So this is no good. So what are my other options? Well, the other options are the ends. And so one end, x could be 0 and y could be 30. And the other end, x could be 30 and y could be 0. So those are the ends. So if you think of this, it wasn't given to you, but the numbers have to go between 0 and 30 to fit in. So if they add up to equal 30, both x and y must be between 0 and 30. So those are your end values. So x could be 0 or x could be 30. A critical number creates a minimum, so it's no good. So if I plug in 0, I get 30 squared, which is 900. If I plug in 30 for x, I get 60. 0 squared is 0. So which is the winner? the question is, what's the maximum value? So find both numbers to be. So if x equals 30, no, 0, and y equals 30, it produces a maximum value. So when x is 0 and y is 30, you get a maximum value. When x is 29, it creates a minimum value, and then have all the other values in between. All right, so that's an optimization question. Now let's start the assignment. So for assignment 5.2, still like assignment 5.1, these are calculus stories, and we have to just embrace a calculus story and believe we can do it. So the product of two positive numbers is 500. So we have, and I'm just going to label it, x is the first number, and y is the second number. And what we know is the product. So x times y equals 300. And that's going to be a secondary equation because we know that. What am I looking for is what I don't know. That's my primary. So find the two numbers so that the sum of the first, that would be x, plus 3 times the second, so 3y, is as small as possible. So I'm going to call that s for small. So here's what we got. So you have x and y. You have your secondary relationship where the product is 300. So the sum of the first plus 3 times the second is that. And now what do? So first of all, I got too many variables. So I'm going to let y equal, and you divide the x. So then take out the y and put in 300 over x. I'm going to clean that up right now in a second. So I can do the calculus better. 3 times 300 is 900, and I'm going to go x to the negative 1 instead of having that fraction. Next, I'm going to take the derivative of that. So the derivative of this is 1, subtract 900, x to the negative 2, and make it equal to 0. So I'm going to add 900 to the other side, and then x to the negative 2 is really x squared. Cross multiply, or multiply both sides by x squared, and then square root. Now, in the question, did it say they're both positive numbers? Yeah. So they're both positive numbers, so it can only be, a critical number would be 300. So I'm going to test 300 out and see if 300 is a minimum. Now, for this, for it to be positive, it just goes from 0 to infinity. So we don't have any adding or subtracting that would create a restriction here. So it just has to be from 0 to infinity, and I have 300. So if I pick a number to put into the derivative, pick positive 1, and you get a negative answer. Pick like a million or a billion, and eventually you get a fraction here. You know, it's 900 over x squared. That's smaller than 1. So this produces a positive answer. So this is a minimum. And the question is, find something that is as small as possible. So you know what? We found it. That is the minimum we're looking for. So x is 300. Y is 300 divided by x. So 300 divided by, why did I say 300? 30. That's the number. So if I still plug in a number smaller than 30 or bigger than 30, the signs match up. But it was 30, because this is 10. And then that's it. It's not a real world situation. It's conceptual, so I'm just going to let it go and not have to write a sentence. Number 2. Let's read this together. The sum of two non-negative. Now, what's the difference between non-negative and positive? Do you know? Non-negative means 0 is included. 0 is non-negative. But when you say positive, 0 is not included. So the sum of two non-negative numbers means 0 is included and positives is 25. Find the two numbers. So first of all, we have two numbers. So I'm going to let x be the first number and y be the second number. So x is the first, y is the second. And it says the sum is 25, so that's easy. And because I know it, that's the secondary. So what you know is the secondary equation. Let me just check one thing out real quick. My phone seems to be blowing up a little. No. All right, sorry about that. So here we go. So the primary then is find the two numbers so that the sum of first, so the first plus the square of the second, is a minimum. So this is what I have so far. Too many variables, so y is equal to 25 subtract x. Substitute in 25 minus x. Do you have the algebra skills to expand this? Press pause and see if you can expand it and see if it's the same as what I'm doing. So 25 squared is 625. Multiply it together and double it, and then positive x squared. So if I put this together, I get x squared minus 49x plus 625. That's what I get. If I solve this, sure I'm doing okay. If I take the derivative, I get 2x minus 49. Make it equal to 0. Add 49. Half of 49 is 20, 20, 20, 20, 24.5. I had to think about it. So I'm going to do a number line for 24.5. And because I have adding and subtracting, if you make this equal to 0 and add x to the other side, I know it goes from 0 to 25, and 0 is included, and 25 is included. But it goes from 0 to 25, all the numbers. So 24.5 is here somewhere. Into the derivative, if I plug in a number like positive 1, it's negative. If I plugged in 24.75, it would give you a positive answer. This created a minimum. And that's what we're looking for, right? We're looking for a minimum. But we still need to do, and then what was the question asking? Find the two numbers. So we have x equals 25. Because it's a minimum, we're good. And then what would y equal? So remember, y equals 25 minus 24.5. So y is 0.5 and x is 24.5, and that produces a minimum value. Again, these are conceptual questions, so I'm not going to worry about the sentence part yet. Number 3. I think number 3 is connected to what we did. Let's see. So number 3 says the sum of the two non-negatives, find the two numbers at the sum of the first and square the second is the max. So it's the same question as number 3, too, but where you're looking for the maximum. So if you're looking for the maximum, what we just found was the minimum. I have to use the end value. So I'm going to do a chart for x and y and x plus y squared. And so I'm finding a maximum value. And so the ends, the biggest number x could be is 25. That means y is 0. And this is 25. Or x is 0 and y is 25, which makes it 625. Obviously, this is the maximum value. So when x is 0 and y is 25, you have a maximum value. So for a minimum value, x would be 24.5 and y 0.5. For a maximum value, x would be 0 and y would be 25. All right, that's number 3. Now we're on to number 4. Number 4. Now it's a real-world situation. Here we go. Fun story. A rancher plans to fence in 3 sides of a rectangular pasture. There's a picture. The 4th side is against a rock and does not need to be fenced. He needs to enclose 320,000 square meters of pasture. What dimensions would require the least amount of fencing? So what do I know is the secondary? So I know the area. So x times y, I know, is 320,000. I know that. And then what don't I know is the fencing. So what equation would be the fencing? That would be 2 x's and 1 y. And I want that to be the least. So that needs to be a minimum. I'll call that L for least. So this is what I have so far. So this is what I know. This is what I'm looking for. That's the perimeter, the fence I need. L is for least. Y is equal to 320,000 divided by x. So I'm going to write this as 320,000 divided by x. And then to write it, to do the power rule, 320,000 x to the negative 1. All right, now we can do the derivative. That's 2 minus 320,000 x to the negative 2. Make it equal to 0. So I'm going to add this to the other side. And then x to the negative 2 means x squared in the denominator. Multiply both sides by x squared. And divide. So half of 320 is 160. And then the square root, well, the square root of 16 is 4. And then you take half the number of zeros. So it's 400 times 400. Now I need to know if that is a maximum. So if I put in a number, remember it can't have a negative value. So this goes into the derivative for L. So here. So if I plug in positive 1, you get a negative answer. If I plug in 500 or 600, you get a positive answer, because this would be a very small fraction. So 2 take away a small fraction. Positive answer. That creates a minimum. And so what I'm looking for is the minimum. So that's my answer. So let's make sure I remember what the question asked again. It says what dimensions? So we already have x equals 400. What would y equal? So it would be 320,000 divided by 400, which would be 800. And then write a sentence. So a dimension of 400 feet by 800 feet would use the least amount of fencing. So a dimension of 400 feet by 800 feet would use the least amount of fencing. Done. Number 5. In number 5, a box is to be made, again, by cutting small squares out of each corner. To find the size of the square cutouts that would produce a box with a maximum volume. And then they said, don't worry, it's not going to be factorable, so I'll teach you how to use a calculator to solve it, and so on. So let's draw that situation. Not everything is labeled on there that I need to label. So let me do that right now. So I'm going to redraw the diagram. I think you should do it too. So, and it's 3 feet by 5 feet. So this is what I did. So if it's 3 feet by 5 feet, so if this whole thing from here all the way to here, if that whole thing is 5 feet, and you take away 2 x's, this is 5 take away 2x. Just like this here, if that whole thing is 30, and you take away 2 x's when you cut them out, that's 3 minus 2x when you take it away. So if I want to find the volume of this, remember when I fold this up and I create my box, that the height of the box is x, and then one side will be 5 minus 2x, and the other side is dimension is 3 minus 2x. Those are all the dimensions of the box. So I have one variable, so I don't need to I don't need a secondary equation. I just have x. So the volume would be length times width times height. So it's x. Each dimension you multiply together to get the volume. Recognize that x cannot be 0. 3 minus 2x, if you made that equal to 0, and divide, and if you did the same thing here with 5 subtract 2x and divide, just recognize the answers that it can't be. So x has to be bigger than 2.5. Or sorry, x has to be smaller than 2.5, I mean, or 1.5. Try it again. So if, let me reorganize my brain here. So if this was 2.5, it'd be 0, and any number bigger than 2.5 would be bad. Same thing here with 1.5. So all the answers actually have to be between 0 and 1.5. So if you have an answer that's outside of 0 and 1.5, you'd have a negative or a 0 dimension, which we don't want. So here, the number has to be less than 1.5, but bigger than 0, so it would satisfy all three. So the restriction is 0 to 1.5. Otherwise, you would have a negative length, or you might have 0 and so on. So that's the restriction we need to work with. All right. So here's our equation, and what I want to do is take the derivative equal to 0 and solve for x. So I'm just going to do that and show that to you. And if there's multiple answers, we've got to pick the one between 0 and 1.5. So let me show that. So in your calculator, you're going to go Menu. You're going to be Algebra and Solve. So you're going to solve an equation. You're going to press Derivative. So you're going to go Menu, Calculus, and just the derivative, x, and then you're just going to type it in. So that would be x, 3 subtract 2x, what's the last one? 5 subtract 2x, and that's equal to 0, comma x. So the comma is underneath pi. It's on the bottom left corner. Oh, is that a 0 or is that something weird? There it is. Okay, so there is that. You take the derivative of that equal to 0 and solve for x. So, oh, invalid, implied multiplying. So here, we got to make this times right here, I guess. There it is. So the x in the parentheses need a multiplying symbol there so it knows what to do. Notice we have two solutions, but only one solution that's between 0 and 1.5. So the only correct answer is 0.606. Because the other one is beyond my restriction. So the other one you would cross out. 2 point whatever is too big, or else you'd have a negative dimension. So it says find the size of a square cutout of 0.606 feet would do what? Would maximize the volume of the box. Done. Let me show you that. So a square cutout of 0.606, remember you can truncate, you don't have to round, feet would maximize the volume of the box. Done. All right, number 6. So number 6 says find the volume of the box in 5 and show to 3 or more decimals what that would be. So in order to find the volume, you'd have to take that answer. So I'm going to show you how to do that. So let me show you. So we have a formula for volume. Do you know how to substitute in properly? So I'm going to show you that right now. So here it is. I'm going to go here. I'm going to highlight. I'm going to highlight, to double tapped it. I'm going to highlight that. I'm going to go Control V for copy. Or is it Control C? Control C for copy, V for paste. So Control C, Control then C. Now it's copied. Just the one on the left. It's copied now. In. And now, let me escape this. Oops. All right, so now I need a fresh line. So there it is. I am going to define it first because I think it's going to be easier than to keep pasting that. So I'm going to, let me clear this. So I'm just clearing it. Then press tab, and then I'm going to put in my equation, which was x times 2x subtract 5. And then the other one was what? 3x subtract 5. So I have my, is it, or is it 5x? Let me look at it again. Three minus 2x, what was I doing? Okay, so 3, that's like completely wrong. That's insane. So 3 minus 2x. And the other one is 5 minus 2x. Okay, so I've defined it in there. And then when I go back here, all I have to do then is go F1 parentheses and then paste. So go Control V, and then you have an exact answer. You have to have the ability to be able to copy and paste to get an exact answer. And then if you round it, you get 4.10. You get 4.104. So you just say the volume at 0.0606 is approximately this. And 3 numbers after the decimal. And you have it. But it's the ability to use your calculator, right? To get that exact answer. Number 7. All right, a rectangle is positioned with 2 points on the semicircle. Find the point xy so that the area of the rectangle is a maximum. So what I know is a secondary equation. So I know y equals the square root of 36 subtract x squared. I want to know what I'm looking for, and I'm looking for the area of a rectangle. So the area of that rectangle is, now be careful here, length times width. Now the height of it is y, but it's 2 x's along the bottom. So I wonder if you know it's 2x times y. So this is given 2x times y is the full area of the rectangle. Not x times y, but there are 2 x's because it's on both sides of the axis. So 2 of the x's, or in other words, go x times y and double the answer. That's the area. Too many variables. So what y equals, the square root of 36 subtract x squared. there is your equation. There's nothing I can do to simplify that, so I have to use the product rule. Recognize that x has to be between 0 and 6. So if x is 6, 6 squared is 36. So 36 take away 36, you'd have no rectangle. So it has to be an answer between 0 and 6 just to know the domain restriction. All right, so I want to do the product rule. So first of all, write this as 2x, 3x minus x squared to the 1/2. Make sure I have room. So that's what I'm going to take the derivative of. The product rule is the first times the derivative of the second. So the general power rule, and then don't forget the hook. So the derivative of negative x squared is negative 2x plus the second times the derivative of the first, which is 2. All right, we're going to make that equal to 0 and do a little bit of algebra here. So 2 times 1/2 is just x. And I'm going to write this 36 subtract x squared to the negative half. I'm going to go back and write it as a square root, and it goes in the denominator. So when it's calculus or algebra, I switch it back and forth. Oh, and I forgot. So the 2's and the half cross out, but I still have a negative 2x squared if I put it all together. So I have the negative 2x and the x, so that's that. Then I have 2, that's the numerator, and the square root of 36 minus x squared. This one actually doesn't have a denominator. There's no negative exponent. So this negative 2x squared, I'm actually going to add 2x squared, 36 subtract x squared. I'm going to add it to the left side. Recognize that I could divide both sides by 2. And then I'm going to multiply. So I'm going to multiply both sides by the square root of 36 minus x squared. So these are going to cross out. And on the right side, a square root times the same square root, you're just left with 36 minus x squared. Add x squared and you get 2x squared. Divide by 2. And then when you take the square root, we know the answer can't be negative, so it's just positive root 18. Now we got to test out positive root 18 to make sure it's the maximum that we want it to be, between 0 and 6. So root 18 is between 0 and 6. And we have to plug it into the derivative to make sure what happened. So recognize here that if I plug in positive 1, I get a negative. If I plug in positive 1, I get a positive. But this is going to be bigger than this because this is just a fraction. So the right side is going to be a bigger positive. Now, if I plug in a number like 5 here and 5 over here, this negative will be bigger than that positive. I would allow you even to use a calculator to plug in a number and see if the answer is positive or negative. So if you plug in a number between root 18 and 6 into the derivative, which is challenging, you do get a negative answer. So in other words, this right here at root 18 is a maximum. It increases and then decreases. So let's make sure that we understand. It wanted the point, right? So I'm going to write down x equals root 18. What would y equal? Remember what y equals up here? Root 18. So root 18 squared is 18. And then 36 take away 18 leaves me with roots. So both would be root 18. So again, I plugged root 18. Root 18 and square, they undo each other. So it's just 36 take away 18. So it's the square root of 18 for both. And then write a nice sentence. So the point, root 18 maximizes the area of the rectangle. And that's what we're looking for. So you can press pause, or you can continue with me. Number 8. Find the area of the rectangle in problem 7. All right. Well, we had the formula for area, and we have what x and y is, and then you just put it all together. So that was the area, 2xy. X and y are both root 18. Put it together and you have your answer. Number 9. A box with an open top has a square base. I'm going to draw that because I don't have a picture. So a box with an open top has a square base. So that means we have the same dimension on the bottom, x times x. I don't know the height of it though. It says if the volume of the box is 4,000. So that's what I know. I know the volume is 4,000. It says what dimensions would minimize the amount of material. And the amount of material to use for the box is called surface area or just area. So that's my goal. Let me see what we got here. So I have a square box. So the square is x and x, whatever that is. It's the same because it's a square. And then the height. So the volume is x times height. And we know the volume is 4,000. So that's our secondary because that's what we know. Here's our primary, what I'm looking for, the surface area. So I have a square on the bottom, that's x times x. And I have rectangles. Well, each rectangle is x times h. And I have 4 of them, x times h, all the way around, and no top. So it's just 4xh. We have too many variables, so I'm going to solve for h. So you get h by itself, divide by x squared. So that's what h equals, 4,000 divided by x squared. I'm going to simplify this now so I can do the calculus. So to simplify it, 4 times 4 is 16,000. And x goes into x squared, 1x on the bottom. So I simplified it. Now I want to take the derivative of that. That's 2x. Oh, and I want to write this as 16,000 x to the negative 1. Now I want to take the derivative. So that would be 2x negative 16,000 x to the negative 2. Make that equal to 0, and then we're going to solve it. So we've done this before. We're going to add 160,000. That's going to be over x squared, because that means in the denominator. We're going to multiply by x squared. So when I multiply by x squared, both sides, you get 2x cubed. Divide by 2, and that's 16 divided by 2 is 8. And then cube root. Well, the cube root of 8 is 2. And then how many zeros do I need after that if it over? So that would be 20. So it's 20 times 20 times 20. What did I do wrong? 16,000? I suddenly got to 160,000. I don't know about that. Right here, I added too many zeros. So anyways, we get here to 8,000, and the cube root of 8,000 is 20. Somehow I had too many zeros. So now I need to see, using a number line, if the derivative, if that really is a maximum. Or do we want to do a minimum? Minimum. We want the least amount of material. Minimum. So if I look here at the derivative, which is right here above it, if I plug in positive 1, I get a negative answer. And if I plug in a number like 50 or 60, whatever, I get a positive answer. So this creates a minimum. So again, you plug in a number here and see if the answer is negative or positive. You can do that. If you can't do it in your head, then take your time, write it out, use a calculator if you have to, until you can't use a calculator sometimes, to see that it's a minimum. So the question was, well, first of all, we have x equaling 20. So that means h, remember h was 4,000. H was 4,000 divided by x squared. So 4,000 divided by 400 would give me 10. So the question again is, make sure I write a good sentence. So the sentence is, what dimensions would minimize the amount of material used? So I'm going to write down a box 20 centimeters by 20 centimeters by 10 centimeters would minimize the amount of material needed. To build the box. So again, a box 20 centimeters by 20 centimeters by 10 centimeters would minimize the amount of material needed to build the box. And there you go. So you found, so what are we doing? Is we read the question. What we know is secondary. What we're looking for, we create a formula, an equation. We make sure there's only one variable on the right side. We do a little algebra. We do our calculus equal to 0. More algebra, may solve it. Make sure it's a minimum or maximum, whatever we're looking for. And then sometimes we got to go back and then make sure I have the other dimension. And then once you have all the dimensions, you're done. Plug it in and you're over. All right. So I think that's the last question for 5.2 and the rest are review. Let me look here. Yeah. So 9 was the last question to do with optimization. So I know calculus stories can be challenging, but we did it together and you have a believability and you work at it and you're going to solve it. So Mr. G Math over and out. I'm proud of you and until next time.